Hello and welcome back. So today in this tutorial we'll be looking at another type of question based on trigonometric ratio of multiple angles. So here is our question, and first we're going to take the left hand side of this equation and try to solve for our right hand side, which is tan 27x minus tan x. So let's first start with our left hand side. So here is our left hand side of this equation. Now we're gonna follow certain steps to solve this. So at first what we're gonna do is uh, here I'm going to multiply both numerator and denominator by cos x for this first expression, and for the second expression I'm going to multiply it by cos 3x on both numerator and denominator. Similarly, for this third expression I'm going to multiply both the numerator and denominator by cos 9x. Now we can apply one formula here. For this part, it is in the form 2 sine x dot cos x. So we have the formula for, right over here we have the formula for 2 sine a dot cos a. It is the formula for sine 2a. So here 2 sine x dot cos x definitely means sine 2x. And then here comes the denominator part. Similarly, for this second expression, 2 sine 3x dot cos 3x is sine 2 times 3x is sine 6x. The same formula here. 2 sine 3x dot cos 3x is sine 2 times 3x, which is sine 6x. And then the denominator part. Once again, 2 sine 9x dot cos 9x is sine 2 times 9x is 18x. So here sine 18x divided by cos 27x dot cos 9x. Now we can write the formula for we can write this sine 2x in terms of 3x and x. So sine 2x is equal to 3x minus x divided by cos 3x dot cos x, plus here sine 6x we can write in terms of 9x and 3x as sine 9x minus 3x, which is sine 6x, and the denominator part I'll write it as it is. And once again, sine 18x can be represented in terms of 27 and 9x, which is sine 27x minus 9x divided by cos 27x dot cos 9x. Now we're going to apply the formula for sine 3x minus x. So we can say 3x as a and x as b. So we have the formula for sine a minus b, which is sine a into cos b minus cos a into sine b. So when applying the same formula here, we have sine a into cos b minus cos a is of course 3x dot sine x, and then divided by this denominator part cos 3x dot cos x, plus, and same for sine 9x minus 3x. 9x is a and 3x is b, so sine a minus b is once again the same formula. And once again I'm going to apply the formula for sine 27x minus 9x. So 27 is a and 9x is b, so sine a minus b is once again sine a into cos b minus cos a into, and then sine b, sorry I ran out of space, and then divided by cos 27x dot cos 9x. Now what we can do is, I'm going to write here, what we can do is we can just distribute this denominator part for both the expression here. So we can write this as sine 3x dot cos x, and then divided by cos x dot cos 3x, and then comes the negative sign here, and cos 3x dot sine x divided by the same denominator cos x dot cos 3x. Now for this part, what we can do is we can follow the same procedure. Here I'm going to distribute this denominator, So sine x. Now once again I'm going to distribute this denominator for the third expression for these two terms in the numerator, so I can write sine 27x dot cos 9x and then divided by the denominator cos 27x dot cos 9x. We have the negative sign here, so minus, and then cos 27x dot cos dot sine 9x and then divided by cos 27x dot cos 9x. Now let us look for the term that gets cancelled out. So here cos x and cos x get cancelled out, and cos 3x, cos 3x, cos 3x, cos 3x, and then once again cos 9x, 9x, cos 9x, 9x, and then cos 27x and 27x. So finally what we can write is sine 3x divided by cos 3x is tan 3x, minus sin x divided by cos x is tan x, and then plus sin x divided by cos x is tan 9x, minus sin 3x divided by cos 3x is tan 3x, and then sin 27 cos 27 gives tan 27x, and then negative sin 9 by cos 9 is tan 9x. So once again we can cancel negative tan 3x and positive tan 3x, positive and negative tan 9x. So finally we have tan 27x minus tan x, and this is our right hand side. This is what we have to solve according to our question, and we have proved. I hope you got the concept for how to solve this question. And finally, yes, thanks for watching.